Welcome back to today's session. In the previous sessions, we had discussed about various problems that we solve in the network optimization model. As I discussed earlier, your network models can be broadly classified into network optimization models and network analysis. From today, we will be starting off with the concept called network analysis, right? So what is this network analysis? Where do we use it? All that we will be learning, and we will be learning few network analysis techniques. So before going into network analysis, see, this network analysis broadly is used for project management. So first of all, what is a project? A project is a series of activities directed to accomplishment of a desired objective. We all know regarding software project development. See, our objective is development of an end product, right? A software has to be developed. But to achieve this objective, we have a lot of phases or a lot of activities involved behind it. So the stages or the series of activities can be, let me say, feasibility analysis, then uh, all your stages of software development life cycle, right? They are all the activities that we will have to accomplish, uh, we will have to do to accomplish the desired objective. So whenever a task has to be done or a work has to be done, the best way to do it is plan your work first, then work your plan, right? So similarly, for today's project or for today's session, first I have planned what we would be doing today. So you people also have to mentally prepare that today's session would be a bit lengthy, right? For a bit extra duration, you will have to sit and listen to my video today. So first, network analysis. Network analysis is a general name given to certain specific techniques which can be used in planning, management and control of projects. So network analysis is one of the important tools for project management. Whether the project is minor or major, obviously it would require certain amount of time and it would involve certain amount of cost. So all these three phases, that is planning, management and control, becomes very much necessary, right? So the necessary information of any particular project or data can be represented as a project network. See, it might be related to the project duration, so the times involved, a time involved for each activity, where it starts, where it ends, how much duration it takes. All this information can be represented in form of a network diagram, right? These techniques are very useful for planning, scheduling and executing large time-bound projects involving careful coordination of variety of complex and interrelated activities. So what are the objectives of network analysis? So mainly it helps us in planning, then it helps us understand the interrelationship between various activities, it helps us in cost control, minimization of maintenance time, reduction in the overall project duration, control on idle resources, then avoiding delays and interruptions, right? These are some of the major objectives of our network analysis. So where all network analysis can be used? The applications of network analysis. So planning, scheduling, monitoring and control of large and complex projects. Maybe like construction of factories, highways, buildings, bridges, cinema halls, all this. It is also helpful to the army in missile development, then even scheduling of assembly lines, then installation of computers and high technical machineries, and even for making marketing strategies. For all such scenarios, this network analysis will be very helpful. So as I said, our scope is limited only towards the techniques involved in network analysis. We don't bother about much about the planning, scheduling and all that part. That will be dealt with the management activities, but we are interested only in the network analysis techniques. So there are prominently two important techniques that we will have to learn. One is called CPM, right? Critical Path Method. Other one is called the PERT, Project Evaluation and Review Technique. CPM was actually developed by EI DuPont for a chemical plant shutdown project about same time as PERT. Then PERT was developed by the US Navy with Booz Hamilton Lockheed on the Polaris missile, that is the submarine program in 1958. See, both these methods have similar calculations, but one major difference between the two techniques are CPM goes with deterministic time estimation and PERT goes with probabilistic time estimates. So anyhow, in detail we will be studying CPM and PERT in the later sessions. So before going into PERT and CPM, construction of a network becomes very important. So that basics we will be learning in today's session. So what is a network? Basically, network is a graphical portrayal or graphical representation of activities and events. It shows the dependency or the relationship between the tasks or the activities in the project. So what do you mean by dependency relationships? It shows the precedence or which activity precedes another activity or which activity succeeds another activity, or it in simple terms, in layman's terms, if at all I have to say, it gives us a logical ordering, what activity should happen after which activity and what activity would follow it, right? That is what your logical dependency relationship actually means. So a network clearly shows tasks that must precede or follow other tasks in a logical manner. So it gives a clear representation of the plan. So it is actually a powerful tool for planning and controlling of projects. Okay? Hope you people have understood. Now, putting this project management aside, for you to understand what is a network, it is nothing but a graph. That's all. Right? A graph is a collection of nodes and edges. Here also we are making use of nodes and edges, but we are calling it with different names. There we called it edges, here we call them activities. There we called it as nodes, Here we call it as events. That is the only difference. The entire representation is the same, but the way we address it, the way we call it changes. That's all. Fine? So we will learn the key terminologies that we will be using in network diagrams. The key terminologies, first starting with activity. All projects may be viewed as composed of activities. See, any project you consider, it will involve a certain number of activities. It is the smallest unit. Activity is actually a smallest unit of work which consumes both time and resources. So the project manager should schedule and control this. So when it comes to a network diagram, an activity is represented by an arrow, right? A line with an arrowhead, right? An activity is represented by an arrow in the network diagram. Therefore, this diagram is also called arrow diagram. Okay? So the head of the arrow shows the sequence of the activities. So it shows the direction of flow, which activity happens in which direction. It specifies the logical ordering. The arrow or the direction shows the logical ordering of the activities. Classification of activities. See, activities can be broadly classified into four types. First one, predecessor activity. Activity that must be completed immediately prior to the start of another activity is called predecessor activity. ಒಂದು ಆಕ್ಟಿವಿಟಿ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಮುಂಚೆ ಮುಗಿಬೇಕಾಗಿರುವಂತ ಆಕ್ಟಿವಿಟಿ ಏನಂತ ಕರಿತೀವಿ? ಪ್ರೆಡಿಸೆಸರ್, ಮುಂಚಿನ ಆಕ್ಟಿವಿಟಿ. ನೆಕ್ಸ್ಟ್, ಸಕ್ಸೆಸರ್ ಆಕ್ಟಿವಿಟಿ. Activities that cannot be started until one or more of the other activities are completed but immediately succeed them are called successor activities. Right? ಕೆಲವೊಂದಷ್ಟು ಆಕ್ಟಿವಿಟೀಸ್ ಕಂಪ್ಲೀಟ್ ಆಗೋ ತನಕ ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗದೆ ಇರುವಂತದ್ದು. ಅದು ಕಂಪ್ಲೀಟ್ ಆದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ನಾವು ಸ್ಟಾರ್ಟ್ ಮಾಡೋ ಆಕ್ಟಿವಿಟಿನೇ ಅದು. ರೈಟ್? ಸೊ ಪ್ರೆಡಿಸೆಸರ್ ಆಕ್ಟಿವಿಟಿ ಅಂದ್ರೆ ಮುಂಚಿನ ಪ್ರಾಜೆಕ್ಟ್ ಆಕ್ಟಿವಿಟಿ. ಸಕ್ಸೆಸರ್ ಆಕ್ಟಿವಿಟಿ ಅಂದ್ರೆ ಮುಂದಿನ ಆಕ್ಟಿವಿಟಿ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕನ್ಕರೆಂಟ್ ಆಕ್ಟಿವಿಟೀಸ್. Activities that can be accomplished together are known as concurrent activities. Simultaneous agi athwa parallel agi, if at all we are able to handle or perform any activities, then such activities are called concurrent activities. Next, dummy activity. An activity which does not consume any resource but merely depicts the dependence of one activity on the other is called dummy activity. See, this is actually not an activity at all. If at all it has to be an activity, it has to consume time and it has to consume resource. But idu time consume ಮಾಡ್ತಿಲ್ಲ, resource consume ಮಾಡ್ತಾ ಇಲ್ಲ. It is used merely to show the logical ordering. ಈ ಆಕ್ಟಿವಿಟಿ ಆಗೋವರೆಗೂ ಇನ್ನೊಂದು ಆಕ್ಟಿವಿಟಿ ಸ್ಟಾರ್ಟ್ ಆಗೋಂಗಿಲ್ಲ. ಸೊ ಆ ಸೀಕ್ವೆನ್ಸ್ ಅನ್ನ ಡೆಪಿಕ್ಟ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ, ಓನ್ಲಿ ಫಾರ್ ದ ಸೇಕ್ ಆಫ್ merely showing the dependence of one activity on the other. If at all we are using a line, or if at all we are using an activity, then such an activity is called dummy activity. It is introduced in a network when two or more parallel activities have the same start and same finish nodes. See, network diagrams, one constraint that we have is no two activities can run between same two events. ಒಂದು ಸ್ಟಾರ್ಟ್ ಇವೆಂಟ್ ಒಂದು ಎಂಡ್ ಇವೆಂಟ್ ಅಂತಿದ್ರೆ ಇದೆರಡರ ಮಧ್ಯ ಒಂದೇ ಲೈನ್ ಇರೋದಕ್ಕೆ ಸಾಧ್ಯ. ಎರಡು ಲೈನ್ ಪ್ಯಾರಲಲ್ ಆಗಿ ಬಿಟ್ವೀನ್ ದ ಸೇಮ್ ಟೂ ಇವೆಂಟ್ಸ್ ಕೆನಾಟ್ ಹ್ಯಾಪನ್, ರೈಟ್? ಇಟ್ ಇಸ್ ನಾಟ್ ಪರ್ಮಿಟೆಡ್. ಸೊ ಅಂಡರ್ ಸಚ್ ಸಿಚುವೇಶನ್ಸ್ ಅಂಥದ್ದು ಯೂಸ್ ಮಾಡಲೇಬೇಕು ಅನ್ನೋ ಸಿಚುವೇಶನ್ ಬಂದಾಗ ನೆಟ್ವರ್ಕ್ ಡಯಾಗ್ರಾಮ್ ನಲ್ಲಿ ಅದು ಪರ್ಮಿಟ್ ಮಾಡದೇ ಇರೋದ್ರಿಂದ ವಿ ಮೇಕ್ ಯೂಸ್ ಆಫ್ dummy activity. The reason why I am stressing it so much is until and unless it is very much necessary, we are not supposed to use dummy activities in our networks. Okay? Understood? Shall we move to the next concept? So after activities, the next concepts are events. So the event is the beginning or end of an activity. The beginning and end of an activity is called event. Events are represented by numbered circles called nodes, right? So the line is the activity and the nodes at the either ends of the line are called events. So the event at the beginning of the line is called start event. The event at the end of the activity is called finish event. Okay? So events can be broadly classified into three types. First one, merge events, when multiple activities are coming into a single event. When one event is marking the finish of multiple activities, then such an event is called merge event. Then the second type of event is burst event. If at all an event is marking the beginning of more than one activity, that is, if more than one line is starting from a node, then such an event is called burst event. Next type of event is merge and burst event. If at all an event has both multiple lines or multiple activities terminating at that particular event and multiple activities starting at that particular event, then such an event is called merge and burst event, right? So it has both incoming arrows and outgoing arrows, not single arrow but more than one arrow. Okay? Understood? Shall we move on to the next topic? So the next term that we need to understand is called path. An unbroken chain of activity arrows connecting the initial event to some other event in the network diagram is called a path. A network is a graphical representation of logically and sequentially connected arrows and nodes representing activities and events of a project. It is a diagram depicting precedence relationship between different activities. So hope you have understood all the terms related to networks. So now we have certain set of rules and guidelines and important information that we need to remember with respect to your network diagrams. See, some of the most commonly committed mistakes while drawing a network diagram. They are called looping and dangling. So we will first look into what errors we will do so that we will remember it and we will not commit such mistakes when we are drawing networks. Okay, so the first one is looping. Looping is known as cycling error and creates an impossible situation, and it appears that none of the activities could ever be completed. So what do you mean by looping? Let me give you a simple situation. Let me say I have an event 1 which gives rise to, or let me draw it so that you will understand it. So let me say this is one event 1. So this is giving rise to an activity called A. Okay, this terminates at an event 2. So event 2 is giving rise to an activity called B, which terminates at an event 3. And this 3 gives rise to an activity C, which terminates at 1. So now what happens? So I start with event 1, I go to event 2, then I go to event 3, then I'll come back to event 1. So there is an impossible situation where I will be reaching the end of the project. The project can never end at all. So this is not allowed in network diagram. So you need to make sure that there is no loop in the network diagram. Second error that we normally do is called dangling. Sometimes a project network includes an activity which does not fit into the end objective of the project and is carried out without any results related to uh, the completion of the project. Such an error in the network is called dangling. See, this sentence maybe does not make much sense to you, but if at all I try to show it diagrammatically, then you will be able to understand. See, every activity should start at an event and should terminate at an event, right? So activity A starts at 1 and ends at 2. But if at all I have an activity, let me say B, whose beginning is marked, we know where it begins, but we have not specified where it ends, or we are not specifying any logical ordering for B. Then what happens? A terminal event or the finish event for it is not defined. So it becomes an activity which starts at 1 and we don't know where it ends. So this becomes a dangling activity, which is not permitted in network diagram. You should have activities which will have a start event and a finish event. Okay? Understood the concept? Shall we move ahead? Right. Rules for network construction. So whenever you are supposed to draw a network diagram, there are certain rules that we are supposed to follow. So we will see what are the rules. A complete network diagram should have one start point and one finish point. See, like in max flow problem, we had one source and one sink. Similarly, in a network diagram for network analysis also, you need to have one starting point and one ending point. Multiple ending points not allowed. Multiple starting points not allowed. So you can have any number of nodes in between, but start node will always be 1 and the end node will also be 1. Okay? The flow of the diagram should be from left to right. Always when I am drawing the network, from left to right, it has to go. That is, all the arrows should be moving towards right. No backward movement. Okay? Understood? So arrows should not be crossed unless it is completely unavoidable. See, when you are drawing activities, if at all you are drawing a line like here and you are drawing one more line like this is not permitted. See, the lines should not intersect. You are not permitted to have intersecting lines. In most of the problems that we deal with, there is no situation which forces us to have intersecting lines. So avoid using intersecting lines. Arrows should be kept straight and not curved or bent. Don't draw lines like this. So as much as possible, it has to be a straight line. Okay? Use straight lines, either vertical or horizontal, or in many cases you might be using oblique. Don't use curves, arcs. According to your whims and fancies, you cannot keep drawing curved lines. Okay? So no event can occur until every activity preceding it has been completed. This means to say every activity should start at an event and every activity should terminate at an event. That means to say, before the beginning of the line also you need to have a circle. At the end of the line also you need to have a circle. So angle between arrows should be as large as possible. What does it mean actually? It says try to keep the lines quite away from each other so that your network diagram does not become cumbersome. It should not be confusing. ಯಾವ ಲೈನ್ ಎಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ಗೊತ್ತಾಗದೆ ಇದ್ದಂಗೆ ಎಲ್ಲ ಲೈನ್ಗಳು ಒಂದ್ರ ಪಕ್ಕದಲ್ಲಿ ಒಂದ್ರ ಪಕ್ಕದಲ್ಲಿ ಒಂದು ಹಾಕ್ಬಿಟ್ರೆ you will not be able to understand the logical ordering in the network diagram. Therefore, see to it that the lines are kept as much as apart as possible. Each activity must have a tail or a head event. No two or more activities may have same tail and same head events. As I said, concurrent activities bandaga you should not have parallel activities. Andre, between the same set of start event and end event, you cannot have multiple lines. Andre, ಇಲ್ಲೊಂದು ಸರ್ಕಲ್ ಇದೆ, ಇಲ್ಲೊಂದು ಸರ್ಕಲ್ ಇದೆ. ಈ ಎರಡು ಸರ್ಕಲ್ ಮಧ್ಯದಲ್ಲಿ you can have one line. This is permitted. But you cannot have one more line which is called parallel activity. So parallel activities ಇರೋ ಹಂಗಿಲ್ಲ. ಇಂಥದ್ದು ಬರಲೇಬೇಕು ಅನ್ನೋ ಸಿಚುವೇಶನ್ ಬಂದಾಗ we make use of dummy activity. ಹೆಂಗ್ ಬರಿತೀವಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಇವೆಂಟ್ ಬರಿತೀವಿ, ಇಲ್ಲಿ ಎಂಡ್ ಇವೆಂಟ್ ಬರಿತೀವಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ we show the activity, and here we put one more event, we show the second activity here. Because there is a logical connectivity between them, dotted line use ಮಾಡಿ dummy activity ತೋರಿಸ್ತೀವಿ ಇಲ್ಲಿ, right? So parallel lines ಬರೆಯಂಗಿಲ್ಲ. Between the same set of two circles you cannot have more than one line. So parallel activities are not permitted. Dummies should be introduced if it is extremely necessary, ಬೇಕೇ ಬೇಕು ಅಂದ್ರೆ ಮಾತ್ರ ಡಮ್ಮಿ ಆಕ್ಟಿವಿಟಿ ಯೂಸ್ ಮಾಡಬೇಕು. ಮೇಷ್ಟ್ರು ಹೇಳ್ಕೊಟ್ಟಿದಾರಲ್ಲ ಡಮ್ಮಿ ಅಂತ ಹೇಳಿ ಎಲ್ಲಿ ಸಿಕ್ಕದ್ರೆ ಅಲ್ಲೆಲ್ಲ ಡಮ್ಮಿ ತುಂಬಿದ್ರೆ ಮಾರ್ಕ್ಸ್ ಡಮ್ಮಿ ಡಮ್ಮಿಯಾಗಿ ಬರುತ್ತೆ. So once the diagram is complete, the nodes should be numbered. So ಈಗ ನೋಡ್ಸ್ ಗೆ ನಾವು ನಂಬರ್ ಕೊಡ್ಬೇಕು, ಬಿಕಾಸ್ ಸೀಕ್ವೆನ್ಸ್ ಹೇಳ್ಬೇಕಲ್ಲ, ಯಾವ್ದಾದ್ಮೇಲೆ ಯಾವ್ದಾಗ್ಬೇಕು, ಯಾವ ಇವೆಂಟ್ ಆದ್ಮೇಲೆ ಯಾವ ಇವೆಂಟ್ ಅಂತ. ಸೊ ಅದಕ್ಕೆ ನಾವು ನಂಬರ್ ಮಾಡ್ಬೇಕು. ನಂಬರ್ ಯಾವಾಗ ಮಾಡ್ತೀವಿ? ನೆಟ್ವರ್ಕ್ ಡಯಾಗ್ರಾಮ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ಮೇಲೆ, ಆಫ್ಟರ್ ಕಂಪ್ಲೀಟ್ಲಿ ಡ್ರಾಯಿಂಗ್ ದ ನೆಟ್ವರ್ಕ್ ಡಯಾಗ್ರಾಮ್, ದೆನ್ ವಿ ಗೋ ವಿತ್ ನೋಡ್ ನಂಬರಿಂಗ್. ನೋಡ್ ನಂಬರಿಂಗ್ ಹೆಂಗ್ ಮಾಡ್ಬೇಕು ಸರ್? ಹೆಂಗಿದ್ರು 1 2 3 4 ಬರುತ್ತಲ್ಲ, ಹೆಂಗ್ ಬೇಕಾದ್ರೆ ಹಾಕೋಬಹುದು ಬಿಡಿ ಸರ್. 1 2 3 4 ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ನಾಟ್ ಪರ್ಮಿಟೆಡ್. ಫಾರ್ that also you have rules. It is called Fulkerson's rule for numbering of events, right? Fulkerson's rules for numbering of events. So what does this rule says? Event numbers should be unique. ಎರಡು ಸರ್ಕಲ್ಗೆ ಒಂದೇ ನಂಬರ್ ಇರಂಗಿಲ್ಲ, ಪ್ರತಿ ಸರ್ಕಲ್ಗೆ ಬೇರೆ ಬೇರೆ ನಂಬರೇ ಇರಬೇಕು. Event numbering should be carried out on a sequential basis from left to right. ಲೆಫ್ಟ್ ಇಂದ ರೈಟ್ ಗೆ ನಂಬರಿಂಗ್ ಮಾಡಬೇಕು. The initial event which has all outgoing arrows and no incoming arrows ಅಂದ್ರೆ ಏನು? ನಿಮ್ಮ ಮ್ಯಾಕ್ಸ್ ಫ್ಲೋ ನಲ್ಲಿ ಸೋರ್ಸ್ ನೋಡ್ ಅಂತ ಕರಿತಿದ್ವಲ್ಲ. ಸೊ that source node will be called the initial event or the start event, right? So that start event will be numbered as 1. Okay, ಅದಕ್ಕೆ 1 ಅಂತ ನಂಬರ್ ಕೊಡ್ಬೇಕು. ನೆಕ್ಸ್ಟ್, ಯಾವ ನೋಡ್ಗೆ ನಾನು ನಂಬರ್ ಕೊಡ್ತೀನೋ ಅದರಿಂದ ಆಚೆಗೆ ಹೋಗ್ತಾ ಇರೋ ಆರೋಸ್ ಅನ್ನೆಲ್ಲ ಡಿಲೀಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅಂದ್ರೆ ರಬ್ಬರ್ ತಗೊಂಡು ಅಳಿಸೋದು ಅಂತಲ್ಲ, ಲಾಜಿಕಲಿ ನಿಮ್ಮ ಅಸಂಪ್ಷನ್ ನಲ್ಲಿ assume those lines are removed. So when you imagine those lines are removed, it will form a new start event, at least one new start event. So that new start event will get the next number. Okay, delete all arrows emerging from all numbered events. This will create at least one new start event out of the remaining events. Number all the new start events as 2, 3, 4 and so on. Repeat this process until you reach the final terminal event. So final event, last event reach ಆಗೋವರೆಗೂ ಈ ತರ ನಂಬರಿಂಗ್ ಮಾಡ್ಕೋತಾ ಹೋಗಿ. ಸರ್ ಹಾಗಾದ್ರೆ ಲಾಸ್ಟ್ ನೋಡಿಗೆ ನಂಬರ್ ಕೊಡೋದು ಬೇಡವಾ? ಕೊಡ್ಬೇಕು, ಅದನ್ನು ಹೇಳಿದಾರೆ ನೋಡಿ. ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್, ನಂಬರ್ ದ ಟರ್ಮಿನಲ್ ನೋಡ್ ಸೂಟಬಲಿ. ನೆಕ್ಸ್ಟ್ ಯಾವ ನಂಬರ್ ಕೊಡ್ಬೇಕಿತ್ತೋ ಅದನ್ನ ಟರ್ಮಿನಲ್ ಇವೆಂಟ್ ಗೆ ಆ ನಂಬರ್ನ ಕೊಡಿ. ಅಂಡರ್ಸ್ಟುಡ್? ಓಕೆ. ಸೊ ಇವಾಗ ಒಂದ್ 2-3 ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣ ಹೆಂಗ್ ಸಾಲ್ವ್ ಮಾಡೋದು ಅಂತ ನೆಟ್ವರ್ಕ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್. ಸೊ ಕ್ವೆಶನ್ ಅಲ್ಲಿ ಹೇಗ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂತಂದ್ರೆ, ಆಕ್ಟಿವಿಟೀಸ್ ಯಾವುದು ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದರ ಪ್ರೆಡಿಸಿಸರ್ ಯಾವುದು ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದಕ್ಕೆ ಮುಂಚೆ ಆಗ್ಬೇಕಾಗಿರೋಂತ ಆಕ್ಟಿವಿಟಿ ಯಾವುದು ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸಿ ಇನ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್ ವಿ ಹ್ಯಾವ್ A, B, C, D, E, F, G and H as the activities, right? A does not have a predecessor, so it is the first activity. B also does not have a predecessor, it is also first activity. C does not have a predecessor, so it is also first activity. So ಈ ಮೂರು activities start event ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾ ಇದೆ. So I will draw 3 lines from one circle which has no activity behind it. So 3 arrows are coming out, A, B and C. So ಈ ಮೂರು activities ಬರ್ದಿದ್ದಾಗೋಯ್ತು. Next activity ಬರಿಬೇಕು. Next activity is D and E and F. These 3 activities are coming out from A. ಸೊ ಎ ಇಂದ 3 ಆಕ್ಟಿವಿಟೀಸ್ ಬರ್ಬೇಕು ಈಚೆಗೆ. ಡಿ ಇ ಎಫ್. ಸರ್ ಹಿಂಗ್ ಯಾಕೆ ಬರೀಲಿಲ್ಲ ನೀವು ಅಂತ ನೀವು ಕೇಳ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಬಿ ಅಂಡ್ ಡಿ ಕಂಬೈನ್ ಆಗ್ಬೇಕು, ಆದ್ರಿಂದಾಗಿ ಡಿ ಬಿ ಗೆ ಜಾಯಿನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಇಲ್ಲಿ ಸಿ ಅಂಡ್ ಇ ಜಾಯಿನ್ ಆಗ್ಬೇಕು, ಅದಕ್ಕೆ ಇ ನ ಸಿ ಸರ್ಕಲ್ ಗೆ ಜಾಯಿನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅಂಡ್ ಎಫ್ ಗೆ ಆತರ ಕನ್ಸ್ಟ್ರೆಂಟ್ ಏನಿಲ್ಲ, ಹಾಗಾಗಿ ಅದನ್ನ ಹಂಗೆ ಸುಮ್ಮನೆ ಮುಂದಕ್ಕೆ ತಗೊಂಡೋಗಿದ್ದೀವಿ. ಓಕೆ, ಸೊ D, E and F are coming out of A. So A in the 3 activities D, E and F come out. D terminates at an event where B also terminated. E terminates at an event where C also terminated, and F terminates at a new event. Right? ಈಗ ನೆಕ್ಸ್ಟ್ ಜಿ ಅಂತ ಒಂದು ಆಕ್ಟಿವಿಟಿ ಇದೆ. ಇಟ್ ಶುಡ್ ಸ್ಟಾರ್ಟ್ ಆಫ್ಟರ್ ಬಿ ಅಂಡ್ ಡಿ ಹ್ಯಾವ್ ಕಂಪ್ಲೀಟೆಡ್. ಬಿ ಅಂಡ್ ಡಿ ಎಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗ್ತಾ ಇದೆ? ಈ ಸರ್ಕಲ್ ನಲ್ಲಿ. ಸೊ ಈ ಸರ್ಕಲ್ ಇಂದ ಲೈನ್ ಬರಬೇಕು ಜಿ. ರೈಟ್? ಸೊ ಜಿ ಹ್ಯಾಸ್ ಟು ಕಮ್ ಫ್ರಮ್ ದಿಸ್ ಸರ್ಕಲ್ and it should reach the end event or the terminal event. ಯಾಕೆಂದ್ರೆ ಎಫ್ ಆದ್ಮೇಲೆ ಇನ್ ಮುಂದಕ್ಕೇನು ಇಲ್ಲ. So it should end at this event only, because I have already told network should have only one starting event and one ending event. So this event also, this activity also ends at this particular event. Next ಇನ್ಯಾವುದಿದೆ activity? H. ಎಲ್ಲಿಂದ ಬರ್ಬೇಕದು? ಆಫ್ಟರ್ ಕಂಪ್ಲೀಷನ್ ಆಫ್ ಸಿ ಅಂಡ್ ಇ. ಸಿ ಅಂಡ್ ಇ ಎಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗ್ತಾ ಇದೆ? at this particular circle, at this particular event. So this activity has to originate from this event. Fine? So H comes from this activity, from this event, and ends at the terminal event. So now all the activities have been represented. Yes. So once the complete network is drawn, what next? We are supposed to put numbers for the events. Node numbering has to be done. So in this network, which is the start event, so this is the start event, so it should get a number 1. Okay, so now assume, imagine lines from 1, this line and this line are removed. So if these 3 lines are removed, which will be the next start node? Obviously this will not be a start node because it has an incoming node, an incoming activity. This also cannot be a start node because it has an incoming activity. So only this activity has no incoming now. Therefore, this node will be numbered 2. Now assume lines from 2 are deleted. So which becomes the start activity or start node next? See, this also becomes a start node and this also becomes a start node. So you can number this as 3 or this as 3. It is your choice. One will be numbered as 3, other will be numbered as 4. Because at the same time both became start nodes, you cannot number both as 3 because node numbers are unique. Okay, so I will number this as 3. Next, parallelly I had got this as a start node. I will number it as 4. Now delete the lines from 3. Did I get any new start node? No. This line was also deleted earlier, but still there is one more incoming node here. So next, from the numbered node 4, delete the activity. Now this becomes a new start node, which is your terminal node. So what is the next number that I am supposed to give? The node number will be 5. So this is how network construction has to be done. Isn't the problem simple? Very easy, right? So we'll see one more problem now. So one more problem. How many activities are there? The activities are A, B, C, D, E and F. So out of that, A is an activity which does not have a predecessor. So only one activity is starting from the start node. So one activity comes out of the start node, it terminates at one more event. So A handled. Next, there are two activities which originate from A. After the completion of A, B and C has to start. So I am bringing out two lines, B and C, from the event where A terminated. So now A, B, C are handled. Next is D. D comes from C. So D comes from C. This activity is done. Next activity is E, which should come from B and C. So B and C should be merged. So if at all they get merged, what happens? It gives rise to parallel activities. And I am not supposed to have parallel activities. Parallel activities are not permitted in network diagram. So what should I do? Because it is very much necessary now, I should have a dummy activity. From where to where? Should it come from B to C or it should go from C to B? So if this comes from B to C, here I will have a combination of B and C. Then D is coming out of B and C, which is not the problem. The problem says E has to come out from B and C. D has to come out only from C. Therefore, my dummy activity should be directed from C to B. C ಹೋಗಿ B ಮರ್ಜ್ ಆಗಬೇಕು. ಯಾಕೆ ಅಂತಂದ್ರೆ ಬಿ ಸಿ ಮರ್ಜ್ ಆಗಿ ಇ ಬರಬೇಕು. ನಾನು ಬಿ ಇಂದ ಲೈನ್ ಸಿ ತಗೊಂಡ್ಬಂದ್ಬಿಟ್ರೆ ಡಿ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ಬಿ ಅಂಡ್ ಸಿ. ನಾವು ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಅದಲ್ಲ, ರೈಟ್? ಸೊ ಐ ವಿಲ್ ಪುಟ್ ಅ ಡಮ್ಮಿ ಫ್ರಮ್ ಸಿ ಟು ಬಿ ಅಂಡ್ ಫ್ರಮ್ ದೇರ್ ಐ ವಿಲ್ ಬ್ರಿಂಗ್ ಇ. ಸರ್ ಇ ಯಾಕೆ ಹಿಂಗ್ ಬರ್ದಿಲ್ಲ ಅಂತಂದ್ರೆ, because my next activity is a combination of D and E. D, E ಎರಡು ಮರ್ಜ್ ಆಗಿ ಬರಬೇಕಾಗಿರೋದು. ಅದರಿಂದಾಗಿ E ನ I am bringing it to the terminal event of D. D terminate ಎಲ್ಲಾಗ್ತಾ ಇದೆಯೋ ಅಲ್ಲಿಗೆ E ನ ತಗೊಂಡ್ಬಂದು terminate ಮಾಡ್ತೀನಿ. Now F has to start from that particular event and should end at a terminal event. So ಎಲ್ಲ activities handle ಮಾಡಿದ್ದಾಯ್ತಾ? So once all the activities are handled, what is to be done next? Numbering. So which is number 1? So without any doubt, this is the node number 1. So delete this. This becomes 2. Delete this line and this line, which becomes 3. This cannot become 3 because there is an incoming dummy. Therefore, this becomes 3. Okay? So this becomes 3. Now delete the lines from 3, which is 4. Obviously, this will be 4. So now delete the lines from 4. Already this line was deleted from 3. So this becomes 5. So now delete the lines from 5. This becomes 6. Any doubt with this? So node numbering also done. Isn't it simple? Did you understand where and when and how to use dummy? Right. Shall we move on to one more problem? Problem number 3. See here, I have activities A, B, C, D, E and F, or also G. The predecessor for A is null and the predecessor for F is also null. So they both are starting activities. So two lines have to start from the start event. So two lines have started. Then B and C starts from A. So two lines are coming out of A. Then D has to come out of B. I am bringing it down to C because E has to start from C and D. So I have brought D here. So E starts from C and D. Because G has to start from E and F, I bring E down to F. Okay. Now G has to start from combination of E and F and has to end at a terminal event. So a single start event and a single terminal event. Correct? Now what next? Node numbering. Which will be node number 1? So obviously without any doubt this is node number 1. So delete the lines from here. Which will be second start event? So this one. So that will get node number 2. Now delete the lines from 2, which becomes 3. So obviously this becomes node number 3. So now delete the lines from 3, which will become 4. This is already deleted. So this becomes a new start event. So this becomes node number 4. Now delete the lines from 4. This was already deleted. This is also deleted now. This becomes the new start event. So it becomes node number 5. And lastly, delete the activities from 5. So this node becomes node number 6. Any doubt with network construction? Is the concept clear? So in the next session, we will be dealing with another method of network construction where the problem will be given in a different type. This is one type where the activity and its predecessor is given. So we will be discussing another type of problem in the next session. Hope you people have understood whatever has been dealt today. If at all you have any doubts, you can post it on the classroom platform. Thank you for your patient listening. Till the next session, have a nice time. Enjoy. Thank you.